me share my screen. You guys can see my screen. Feel free to, along the way, talk. You are allowed to turn on your microphone. Feel free to chat as well. I will be looking, so I have two screens. In here, I'll be looking to the messages. So always feel free to let me know if you have questions along the way, okay? So without further ado, thank you for coming. This has been a great partnership with 42 Blockchain. Yeah, I think it's really exciting to have people from all over the world as well. In my case, I'm from Portugal. I'm based in Porto, beautiful touristic city, very sunny. Yeah, we are from the PT hub of ICP, but also there is the French hub that we are currently helping out, and we are in contacts with different hubs. Towards the end, I'm going to share with you guys some links. So if you are interested in also connecting to hubs that are not Portugal and France, something that is closer to you, I will also share in the end a link to it as well. So maybe a little bit about me. My background is as a full stack Web3 developer, maybe 8 years or something like that. Then I've done this boot camp maybe 2 years ago. And I was fascinated. I was looking for something different to do, and I was fascinated by what ICP was already doing. Like, it's not something on the roadmap. It's actually something I could play with. And since then, I've been very excited for the technology, that what it allows you to do, how some of these things are really easy to do. And since then, I've been on the hub trying to be a tech lead, onboarding developers as you, but also accelerating teams. We currently have 5, 6 startups on the hub. Some of them doing some really exciting stuff for the ecosystem. And on the side, I like games. I wish I had more time to play nowadays. But one of the ones that I've helped out, I did not build the Unity part. I built more the blockchain website part. It's called Obsidian Tears, which is fully decentralized, 100% on-chain RPG game. And I'm going to show a little bit some demos about games. Yeah, some a bit of a geek in there. So first things first, what is the IC? What is this ecosystem? What is this technology? What does it allow you to do? So before I go deeper, I would like to start maybe with this definition. Try to see the IC as not just a blockchain like Bitcoin, but something a little bit more powerful that allows you to become a decentralized cloud. So try to think that you can host almost anything. You can do general computation on top of it. And the way that it behaves, it's a lot like if you were interacting with a decentralized cloud. You will focus more on the code side of things and not so much on the infrastructure side of things. I don't know if any of you has had any connection with the DevOps, but sometimes there is even this job where the only thing that you do is understanding about infrastructure. And is the server down? Is the server doing balance loading? So there's a lot of things that you need to worry about infrastructure. In the case of the IC, it tries to abstract it away, and because it's decentralized, like you don't need to worry about that because the foundation and more technical people, the node providers, etc., they're caring about the infrastructure layered for you. You only need to care more about the code itself, and it behaves a lot more like serverless functions, as you will see now. You will see soon. Before I go deeper into code or examples, I usually like to explain not what blockchain itself is. I think a lot of you already know, but this historical overview of how things have evolved, so that you can also notice the difference between different blockchains and different generations. You go to CoinMarketCap, you have thousands of them there, but underneath the hood, they have very different purposes, very different architectural choices in there, and you could, yeah, understanding why and where they are coming from. I think it's important and relevant here. So the first generation, we could think of Bitcoin, for example, and the main thing that it was allowing is a shared database ledger. So it fixes this double spending problem where you know for sure that if you have Bitcoin in one address, you don't have that exact same Bitcoin in another address. Like, this would never happen. So you have found a way that in a decentralized database, they can come into consensus and all agree on how or who should have a certain amount of Bitcoin. And that solved and allowed for Bitcoin to become a store of value. And you have many other ones out there. And the main thing here is that it doesn't have any logic besides just a transfer of currency. Okay, so on the second generation blockchain, as Vitalik is famous for saying that he was so frustrated that he could not do certain activities, and he wanted to allow Bitcoin to be kind of a world computer where it allowed to execute things on top of it. Because it was already a shared database, why not be a shared computer, right? So what it tried to be is that, like, try to have transaction logic on top, try to have logic on top of the transactions. And that already allowed for many things that you probably are aware of: stable coins, the NFTs, ICO, so pretty much any cryptocurrency out there, man tokens, I didn't put here, but DeFi, so trying to earn yield on top of your investments. And because of that, especially around DeFi, you have so much transactions, so much value being extracted from here that yeah, it has a lot of different different blockchains that try to solve the scaling problem, layer twos and different features associated with it. But all in all, they are very focused on being transaction logic purpose. It's still very focused on you have a blockchain, and if you do a transaction, do a consequence after it. And it doesn't yet fully allow a lot of this general computation or to host stuff in top of it and things like that. So on a third generation, going again from the frustrations of trying to do more with the current technology, you're starting to see some blockchains trying to do things like you go to a website, you're not even aware that this website is hosted on chain, but a DAO can actually control the full DApp experience. It's not just the blockchain, but actually the full game can be hosted on chain. The full DApp can be like the full Twitter, the full financial operations, the financial app that you are using can be associated, and some more connectivity like HTTP, like directly talk to the smart contracts. Don't need to always go through RPC, for example. Allowing people not to need to use wallets. You can use still accounts, but you don't need this extension on the browser for you to interact with it. And yeah, based on a lot of this frustration, yeah, for example, another one that is a more recent one, only started to appear after I joined the IC, that is AI. Running AI on chain, like, how are you going to have AI agents or models actually running in a blockchain in a decentralized, distributed manner with the old technology? You just can't. So try to think that the IC is state of the art regarding distributed systems. If you are, for example, a researcher, try to go deep into what the architecture is. There are some choices in there that solve some very interesting problems regarding distributed systems. And basically, as a developer, try to think that you have serverless functions, but in this case, it's stateful serverless functions. I don't know if I've ever played in AWS with Lambda or in any of the other clouds. You usually have serverless functions. You pretty much just put there the JavaScript, you attach to it an API, an HTTP gateway, and that's it. It can interact and receive, and every time that it's receiving, certain consequence happens afterwards. And it's only executed as needed. And that's just in time kind of execution makes it super efficient regarding costs. Okay, so if you're constantly updating, maybe running things on a blockchain is not so interesting. But if you are just hosting a website, hosting a game, like I have my game and it's costing me like $5 an entire year, just hosting it on chain, and it has 300 megabytes, something like that. And it's really cheap. It's hard to find cloud providers that would host a game that's so cheap. And the reason for that is because the architecture of it is a lot just in time. Like its serverless functions is there is a new request. If it hits cache, return, don't care. If you are updating and making a change in the blockchain, then that's only the moment that you will need to go through the consensus of all these nodes. Okay, so all in all, what does it allow you to do? It allows open services, and it allows for this vision of Web3 to be complete, to be finally complete. You can actually have a DAO that fully controls code, that fully controls the revenue streams that are coming from that DApp. And different people, from a startup to an entire community of thousands of people, like Wikipedia, for example, could be receiving and having automated ways that they are handling either the control of stuff or the control of the profits that they are earning, for example. Um, it allows for secrets. Imagine hosting emails. That's something that's was always weird, that you are having a dApp. It's decentralized, but then this dApp, because everything is public, doesn't allow you to host emails and send emails, for example. So there are some cool things that it allows because the architecture is also very different. Okay, and there were some architectural choices in there that it's very important to be aware of. But nowadays you can do things on the blockchain that is, I think, it's really cool. Before I go to the examples, I just wanted to show you the dashboard of Internet Computer, so that you are a little bit aware of, like, when I mean that it is a decentralized cloud built on blockchain technology. This is what I mean. Like, it actually has a DAO that is overseeing the onboarding, the open onboarding of different data centers that all have the same kind of specs of machines, so that the computation that is running is kind of robust and predictable. And it's regionally distributed. Okay, so you pretty much have data centers all over the world, and you have boundary nodes all over the world, and different providers. So it's not, although you have different nodes, it's always independent providers, like, so that they cannot, or it's not expected that they will collude and do something nasty for a certain subnet, for example. And be aware that each subnet, so there are 37 subnets, each subnet holds 30 nodes. That means that it has at least always on that subnet. There are also turned on but not being used nodes. Okay, And these nodes can always be used if there is one that goes down or one that lacks in the performance. It can always be replaced. But all the subnets have 13 nodes, and always they need to have consensus between them to agree on stuff. And I wanted to show a subnet, and you have proposals on the yeah, subnet. Imagine this subnet, you can see how it's immediately regionally distributed. And for example, the examples I'm going to show, imagine it's a game. You deploy it, and as soon as you're deploying, that takes seconds to deploy. It's going to be replicated all over the world. And every update that you are making, a change in the leaderboard, a change in something in the app, a message that you are sending in this open chat I'm going to demo, be aware that it's being completely replicated across the globe by default. So if your projects, or if you can imagine projects that could benefit from being globally replicated, maybe hosting something on chain could make sense. Okay, so I'll go now to OpenChat. OpenChat is I have, because the time is not a lot, I can in Q&A go to different I can go to different examples, okay? But I've tried to pick a few ones, the best ones. So OpenChat is like Slack and Telegram getting together, or Discord. And the best of it is that it's entirely hosted on chain. Like it's a DAO. It was the first SNS. They call it like that, the DAOs. It has proposals. Okay, so whenever someone wants to update the code, like all the front end is hosted on chain. If someone wants to update the codes, they need to go through this proposal. The DAO needs to, or has the chance to review. And it's very public. If something goes wrong, like at least people can know what happens, and work from there. Like usually they have links to the commit so that people can review, people can build the WASM. So WASM is WebAssembly, everything on the blockchain, on the IC. In this case, it's running on WASM. Same as several other ones. Solana is also hosted with WASM. Several other ones are using more and more nowadays WASM because it has these properties where a data center, a node can run in parallel, in a very secure way, important sensitive stuff. And you wouldn't have the risk of a hacker trying to go through the threads, try to go and understand better something else, you know. So WASM is a very safe way of having these parallel environments, virtual environments. And yeah, it's the base of everything that you are seeing. In the end, it's just a WASM that was compiled, and it can be compiled from Rust, can be compiled from TypeScript, can be compiled from Atoko, the language that is on the IC, can be compiled many other languages, but these are the most used ones on the IC. And as long as you have that built, you can review on these proposals. Okay, so usually they would have the way that people can verify and so on. So this is the technical part. The cool part is that every user, for example, has a canister, has a smart contract. One of the cool things about the IC is that every smart, it has threshold key derivation, and you can have every smart contract has their own private keys. That way, a smart contract can hold private state. It can hold, for example, emails, it can hold messages, it can hold these things. And only the controller of those smart contracts can get access to the data or what is happening with it. Okay, and make actions on top of it. So if I wanted to, on my canister ID, do some actions, I am the only one that can. Okay? Outside of the DAO itself, that is constantly upgrading the smart contracts as well. And what else? Yes, so pretty much you have private data. You can store images, and in a very efficient way, actually. You see, for example, I'm talking, so this is a little bit more private, so I'll probably close. But you understood what the DApp already can do. Do you like it? Do you think it's cool that you can actually host fully on chain the front end? Usually people cannot hold on the front end such stuff. And going back to my presentation, the next example that I want to show is AI on chain. So a lot of people are claiming to do AI on chain, but it's not. It's yeah. um Mostly, I hope you can see. I'll try to put it big. In this example, what is happening is that this mod club dev, it's a front end hosted on chain. It has JavaScript. It has this part that is recording this is a KYC, by the way. It's a KYC provider that has verified credentials, and the way that it works is that it will have an AI model that's going to recognize your face. So it has these part of the algorithms to recognize your face and derive a hash from it. So that if you come back again to this service, it will know that you are the same that has come in the past. So it's from this hash. Yeah, but it's running an AI. So she has finished the recording. That recording is going to the backend. The backend has an AI model that will be processing it, and the backend is fully on chain. It's Rust, and after some seconds, as she will show, she will have a verified credential. And yeah, so but the most important part is you can actually run AI models on chain. On the bootcamp, we will show and allow you guys to deploy that WASM to your local host, and you can actually interact with a small model on your computer because you don't have the same capacity as a large one. But at least on your computer, you can definitely hold ChatGPT 2, for example. And yeah, it's cool that people can actually interact, and it's running the inference on chain. It's not running the training part. Okay, be aware of some differences in there. But yeah, you can run inference on chain already. There are some improvements, some very exciting improvements that will come out in the next months. We will also have a dedicated subnet. I've showed you these subnets. They hold mostly CPU kind of machines. But the goal for next year, for already this year, is to host AI subnet. So they're already onboarding, starting to define the standards for that machine, for that GPU machines that would be capable of running faster and stronger inference. And yeah, it will be really cool to see some AI on chain unstoppable, kind of. So a little bit some. I hope you like some of these examples. I now have 2 decentralized games. As I've mentioned in the beginning, I love games. So feel free to, on your browser, just write down icpsaver.com. That is the first one. And then thecubetopia.com. That will be the second one. Okay. And this is being hosted fully on chain. In here, it's a demo game about the IC. You can learn more about it. It will explain. There are trolls. You need to help me understanding more about it. It's going to explain stuff, and you can just play. It's in Unity, the game, but it's hosted on chain. And I wanted to show the inspect. Where are you? So in here, what's happening is that ICP Savior is a custom domain. It's getting to the boundary node. Then the boundary node is going to the canister. This canister is a special type of canister or smart contract that is called an asset canister. Asset canisters can hold any file, any JavaScript, any HTML, any Unity file, anything. So it's getting there, and then it's asking on the HTTP request method. It's getting a response, okay, and it's getting also and generating an IC certificate. Like one of the things that you can know for sure if you are in contact with front end that is hosted on the IC or not is actually just going to the headers and double checking if there is these IC certificates. They're used to validate through the boundary node so that your browser knows that there was no way that the boundary nodes changed anything between you and the smart contract. Okay, and yeah, so pretty much it's returning it. Then it's going to return on the HTML. It's going to load the JavaScript and everything else, and pretty much you will have the game WASM. In this case, it's Unity game, but it was compiled to WASM. If you ever played with Unity, you know some of the stuff and the data and this is the broadly compression that it has, and the game loader JavaScript. So this is typical from Unity. The other one is so let me go to the other one. The Cooktopia. This one is 3JS, so it's not um, the same as the other one, Unity. This is 3JS, and the really cool thing about 3JS is how fast it is in loading. Like, even if I destroy cache, it's really fast. And on your mobile phone, you can also play it, and it's amazing how it can get and render thousands of components, elements, and and it still renders very, very fast. So I think that the future of these experiences is a lot on chain and a lot on the browser, because using technologies that are very web focused, that is like 3JS. I'm already seeing some of you there. So the full game is hosted on chain, less the positions of the players. Okay, so we are all here playing, having fun, and the front end is hosted on chain, the back end is hosted on chain, it's hosted with TypeScript. So if you're a fan of Next.js, like having the front end and the back end, everything TypeScript, you can do that and then compile everything to WASM. But be aware, because the positions of the players are not on chain, because it's constantly updating. And we have a 2-second finality to update these records across all these different nodes, which is incredibly fast, but it's not as fast as we need for a game. That's the kind of game experience where you don't want to see the lag at all. So for that, usually they just use, I think it's DigitalOcean or something, that they are using a specific server for it. Maybe they are using the one of Unity, I don't know. But pretty much they are using already a specific multiplayer thing. Hey, Azure. Horizon just got past me. Come on. I gotta beat you. Okay, so that was it. I hope you enjoyed it. The best part of it is that it's very cheap to host these games on chain, because you are not paying, it's hitting a cache. And right now on ICP, you're not paying for query calls for reading the data, not even the bandwidth that you are getting. It could be 1,000 players. If it's just static, it's not costing you almost anything. So you can, for $5 a year, host an entire game on chain. So I hope you liked it. It's usually the cool stuff.